Hello. Sorry, I was just playing today's Wordle. If you've not heard of Wordle, I guess you've not used the internet in the last few months. But if you have, you've probably been wondering, what's the best strategy? And the question which seems to generate the most discussion online, what's the best opening word? Just in case you have somehow missed it, Wordle is a game where you get 6 attempts to guess a 5-letter word. The best way to explain is probably a quick example. You start with a blank canvas, and then you make your first guess. I like to start with stone. When you make a guess, Wordle colours any letters that are in the word in yellow. So whatever the mystery Wordle is here, it contains a T and an O. And it colours any letters that are in the word in the right place in green. So that N is clearly where it's meant to be. Then I guessed audio, to test out a few other vowels. So now we know the solution contains a U, and the O we already knew about. And then after a process of elimination, I guessed mount, which is the answer. And in the spirit of only sharing your best Wordles on social media, that's the one I chose to use as an example for this video. But having solved the day's Wordle, what can you do to fill the 24 hours before the next one is released? The answer is obviously maths. Understanding the maths of Wordle can teach us the optimal strategy for winning, because while it masquerades as a word game, the real puzzle here is mathematical. Since the words are picked at random from a list of over 2,000 possibilities, you don't have any real hope of guessing the word on your first go, or even your second. These turns are exploratory fact-finding missions, where you hope to use the information gleaned from your guesses to work out as much about the mystery word as possible, and narrow down the possibilities so you can strike in later turns. As such, there's a lot of discussion online about the best first word to pick to gain the maximum information. One common strategy is to think about which letters are most common in the English language, and pick a word that's rich in those. On that basis, a common choice of opening word is adieu. It contains every vowel except O, so it's quite likely it'll give you at least some information about the next word. And if it doesn't, you know that the only vowel it can contain is O, which will narrow things down significantly too. Another popular choice is audio, for the same basic reason. And I also chose my opening guess, stone, because it contains some common letters, and maybe gets a few extra points because S is the most common first letter for an English word. However, even though it sounds intuitive, this strategy actually isn't optimal. It's not terrible, don't get me wrong, but we can do better using maths. Rather than maximising how common the letters are, the way to win Wordle is to maximise the entropy. You might have heard of entropy as the physics word for disorder. The second law of thermodynamics states that entropy tends to increase, and stuff will tend to move from an ordered state to a disordered one. If you start with a bunch of atoms on one side of a box and remove a divider to allow them to move freely, they'll spread out to fill the whole box, which is a state of higher entropy. And it's very unlikely they'll all end up back in a low entropy state, like being together on the same side of the box again. The mathematical equivalent here in Wordle is that we want an opening guess that creates the most complex, information-dense patterns among the possible solutions. Let me show you what I mean by starting with one of the worst choices of opening word in Wordle: fuzzy. If you guess fuzzy, the most common pattern of colours you'll get back in response is this: all grey. That's because of the 2,315 words which are possible solutions in Wordle, 1,352 of them don't contain an F, U, Z or Y. We can represent this on a graph, showing the percentage of solutions that would give you 5 grey squares if you guessed fuzzy. It's 58%. The next most common pattern you'd get is 4 grey squares followed by a green, meaning that today's Wordle must end in a Y. There are 265 solutions which end in Y, which is just over 11%, so let's add those to the graph too. The next most common is grey, yellow, grey, 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 meaning a word which contains a U somewhere other than the second position, and there are 228 of these in Wordle, representing another 10% of possible solutions. We can go through all the possible solutions, finding out what pattern of colours they would give if you guessed fuzzy, and add them to the graph too. What you can see from this graph is that fuzzy gives you almost no information about what the solution to today's Wordle might be. Over half the time you get all grey, and most of the rest of the time you only get a single extra letter. The large blocks of uniform colour on this graph mean that fuzzy is a low entropy opening guess. You can write a computer program to go through and test all the possible opening guesses against all the possible solutions, and work out the patterns you'll get for each, and then find the one with the highest entropy. And the answer is SOARE. No, me neither. Apparently it's an obsolete spelling of soar, like birds do in the sky. But let's go through what might happen if your opening guess is SOARE instead of fuzzy. The most common pattern is actually still 5 grey squares, but drawing a blank like this is far more informative with SOARE. There are only 183 Wordle solutions that don't contain any of S, O, A, R or E, meaning that you've narrowed down the field of possibilities to just 8% of them. The next most common is a yellow in the middle, and there are 120 solutions which fit this pattern, so another 5%. If we go through all the possible solutions and find out what patterns they'd give if your opening guess was SOARE, the graph looks something like this. Mathematically, this far richer, more complex graph of possible patterns you get with SOARE has a higher entropy than the one we got with fuzzy, which means it contains far more information. And that's why a high entropy guess is the best way to open a game of Wordle. The pattern of colours your guess reveals is far more likely to tell you something about the solution. So, even though SOARE is a stupid word, it does seem reasonably intuitive that it's a helpful opening guess. But what's really interesting is to see how the computer plays later moves, to see inside the counterintuitive, highly optimised mind of an entropy maximising machine. Let's pick a Wordle and let the entropy maximizer play. Its opening guess is SOARE, obviously, which means we've already correctly guessed the first, third and fourth letters. Want to have a think about what you'd go for next, given that result? Well, let's see what the computer tries. Kempt. Kempt, which matches no letters at all. And then, on the next turn, found. No letters again. And finally, scary. The answer got it in 4. What the hell? What's with those two totally random-looking guesses in turns 2 and 3? Well, things get a bit easier to understand if we look under the hood at the computer's thinking. After guessing SOARE, there are 11 words that could give the pattern it saw. So that's why it chooses Kempt. The K, P, M and T are a great way to uniquely identify most of the options here. And when that comes up empty, it knows it must be one of the 4 remaining words that don't contain any of them. Then it picks found, which contains unique letters from 3 of those 4. And when it finds that none of those match, the Wordle must be scary. Isn't that some amazing lateral thinking? So, should you start every game with SOARE from now on? Aside from the fact it might feel a bit dirty to have had computational assistance. Well, maybe not, because there are a couple of problems with this technique for identifying the best opening word. One mathematical, one linguistic. The mathematical problem is that this algorithm of maximising the entropy in a given turn is short-sighted. It might be that a particular guess maximises the diversity of patterns this time, but makes life hard in the next guess by grouping together a bunch of words that are hard to separate with guess number 2 or 3. To see if this really is a problem, I tried the top 100 best words for maximum entropy on turn 1 to see which would win the fastest on average. And that changed things significantly. Opening with SOARE wins in an average of 3.64 turns, which puts it in 41st place. The winning word now is Reist. Reist? Nope, no idea what that means either. But it will nail a Wordle by entropy maximisation in just 3.60 turns, about 1% faster than rubbish old SOARE can manage. And Reist probably isn't the best word either, because when I worked that out, every subsequent turn was also played without looking ahead to turns after. Out there in word space, there's some highly optimised branching sequence of guesses you could try to win any possible Wordle as fast as possible. And my guess is that that would change the best opening word again. However, given that we got less than a 1% improvement for optimising the critical first guess, I'll leave this computationally intensive and probably almost thankless task of generating the optimal Wordle guess tree as an exercise for the reader. This short-sightedness is even more important in Wordle's hard mode, where every guess has to include the correct letters from your last one, meaning you can put yourself in a corner by getting too many letters right, restricting your options for high-entropy fishing expeditions. But, just in case you're interested, the short-sighted algorithm finds that the best opener in hard mode is Trape, with Reist dropping down to 5th place, which is evidence there's something going on. Also, you can see that even the best words take an average of 0.2 more guesses to find the answer. So hard mode is harder, but perhaps not as much harder as you'd think.
The bigger issue is the linguistic one. I don't care how much of a word nerd you are. No one on the planet knows every one of the 13,000 words that Wordle would accept, much less can call on them at random to come up with an entropy maximising guess during a game. So I did the same thing again, but this time tried to filter the list for words you might actually have heard of.
And after all that, the winning opening word is trace, which will solve a Wordle in an average of 3.62 turns if used by an entropy maximising algorithm that's only allowed to guess normal words. The guess distribution looks something like this, with 40% of games taking exactly 3 guesses and 53% taking 4. The same algorithm starting with internet favourite adieu averages 3.83 turns to win, and my opener stone takes just 3.69, which I'm pretty happy with. Interestingly, if you run the same calculation for hard mode, trace wins there too, in an average of 3.84 guesses. I've put some lists of the top best opening words in the description, so you can check out where yours ranks, or doesn't. Trace still might not be the best opening word for you though, because you're not playing the game like a computer would. My apologies to anyone watching who would have followed SOARE with Kempt earlier, but I'm guessing most of us would have played that one rather differently. But I think the computer's mad skills are an extreme case of an intuition you get when you've played Wordle for a while. Sometimes the best guess isn't the most likely to be correct, but one that splits up a field of possible answers. Since looking into the maths, I've been keeping an eye out for the unconventional entropy maximising guess when contemplating my next move. Mathematically, most of the opening words for Wordle which aren't obviously terrible will give you a chance to win in 3 or 4 turns. Playing perfectly, you could win with 4 guesses 9 times out of 10. But don't be too hard on yourself if your guess distribution doesn't quite reflect that, because you're not an entropy maximising computer which can make almost instantaneous comparisons between thousands of possible words. The most important lesson is, don't pick fuzzy. And the second most important lesson is that the meta-puzzle of mathematically finding the optimal solution to a puzzle is often just as fascinating as the puzzle itself.